Hello everyone, welcome back to my channel. I am Shikha and today we are going to discuss about machine referential model. In cloud computing, this is a topic that is machine referential model. So today I will be telling you guys about this. Now, first we will start by the uh, introduction part. So introduction of machine referential model. So it is nothing but it is a virtualization, that is when an execution environment is virtualized at unlike levels of the stack of computation, then it requires a referential model. Then it requires a reference model because it is that execution environment. It is a virtualized, so it requires for its computation. It requires a reference model that defines the interface within the levels of abstractions, and this level of abstraction hides the details of implementations. Now, this project this projects an idea that virtualization techniques can substitute any one layer and can intercept the cells which are directed to it. So this is the introduction, and as you can see in this figure, for this virtualization, we have as in this diagram you can see they are the machine. It means this model, it is designed in a way. So now we will explain these all the calls and all one by one. Now, the instruction set architecture, that is also called as ISA, we can tell it defines the instruction set for the processor, registers, memory, and interrupt management. Means the instruction set architecture, it defines the instruction set for processor. Means that instruction that we set it for the processor or registers or memory and interrupt management. It is an interface between software and hardware. It acts as an interface between software and hardware, and it is mandatory for operating system because this only it is defining the instructions. That means it is a way to the from the processor, and it is from the processor means from hardware to the software. So this is very mandatory for the operating systems developers, system ISA, developers of applications who directly manages code hardware, user ISA. The operating system layer is separated by application. Means this operating system layer, this it will be separated by the application binary interface, that is called ABI, from the application and libraries which are managed by the operating system. So what this instruction set architecture, it is a set, it is the it defines, it is, you can tell it is an instruction set library type which is set for the processor, registers, memory, and interrupt management, so that it can, so that because it is as an interface between software and hardware, because this means to connect them as this operating system layer, it is separated by the application binary interface. So from the application and libraries which are managed by this operating system, so we require this instruction set architecture. Now, the another one is application binary interface, ABI. ABI covers facts such as low-level data types and call conventions, and it also defines a format for many programs. Means it covers a fact such as low-level data types and all the convention, and it also means it defines a format for the many programs. This application binary interface, it tells us about the formats to how to design the program about for the many programs. As here we already told that key this because this operating system layer, it is separated by the means this operating system layer, it is separated by the application binary interface from application and libraries that operating system have to manage. So as this ABI, it covers, it defines a format for many programs. Mainly system calls are defined at this level. Means the system calls are defined in this level. Moreover, this type of interface enables portability of various applications and libraries across OS which employ the same ABI. Means this is mainly the system calls are defined at this level. Means at this level the system calls are defined so that to perform the to perform the action or to implement, because it provides the format for the program set. So now this application programming interface. Now what is application programming interface? It is represented by the highest level of abstraction. So this API interface applications to libraries and are the core of OS, operating system. Means this API, it interfaces the applications to libraries or the core of operating system. For an action is to be performed in the application level API and the two which are responsible to make it done. API and API are the two which are responsible to make it done. Now, mainly CPU runs in two privilege levels. Means for processor to run it, there are two levels, that is user mode and kernel mode. User mode. In this mode, memory access is restricted upon some limit, whereas means in user mode, so whatever the memory already we have in our system, means we have, that is means for one what if we design or if we are assigned the memory key for this, we have to use just this much memory. So means it is a restricted memory access is restricted for to some limit, whereas access to peripherals is denied, means we can't access these peripherals. Now for kernel mode, in this mode CPU has instructions which manage memory and how to be accessed, and it also has instructions which enable access of the peripherals like disk and network cards. Means in kernel mode, CPU has instructions which manage memory and how to be accessed. Means in kernel mode, this CPU, this only will manage the memory. It has no restriction, because whatever the memory it has, it will only assign for the memory for the users to use, and how to be accessed, and also how the instructions which are enable access of peripherals like disk and network cards. Now, as you can see in this figure, the this whole kernel mode, this is divided into three types, that is ring 0, ring 1, ring 2, and ring 3. Now this privilege, this are ring 0, this is also called as most privileged or supervisor mode. And whereas this in privilege mode, that is ring 0, ring 1, ring 2 are come, and the least privilege or user mode, that is ring 3, as this user mode only is the restriction, memory restricted mode, means, and it can't access to the privilege mode, because it has, you can see it is showing list privilege, means it is denied the access of privilege. The expansions and application of computing systems are simplified by this layered approach. Means means because of this layered approach, the expansion and applications of computing systems are simplified. Applications of multitasking and coexistence of multiple execution is simplified by this layered approach. And means these are the advantages, and this the first can be made within privilege and the non-privilege instructions. Now those instructions which can be used with interrupting with another task are known as non-privileged instructions, and they are also called so because shared resources are not exist. Means those instructions which can be used with the interrupting with the task are known as, means in non-privileged instructions. See here, as you can see, this non-privileged instructions, they are which can be used with interrupting with another task. It's like while continuing in one task, we can do another task also. So that is called non-privileged instructions. They are also called so because shared resources are not exist. The instructions which are executed under particular restrictions and which are frequently used for sensitive operations, they are called as privileged instructions, which pose behavior sensitive or modify control sensitive. Means the instructions which have some rules and restrictions for the performance of the or using the sensitive operations, that are called as the privileged instructions. These are all for this machine. As we talk differential models, so these are all about this machine differential models, kernel and user, and from this we can access this privilege mode and non-privilege mode. Hope you guys understand this video and you got to understand about the machine differential model. Thank you.